Welcome to EPA's online training series for the Water Quality Surveillance and Response System, or SRS program. This primer module provides basic information about the design and objectives of the Consequence Management, or CM component of an SRS, and describes how it can be used to detect water quality incidents in drinking water distribution systems. An SRS provides a systematic framework for enhancing distribution system monitoring activities to detect emerging water quality issues and respond before they become problems. It consists of 6 components grouped into 2 operational phases: surveillance and response. The surveillance components include online water quality monitoring, enhanced security monitoring, customer complaint surveillance, and public health surveillance, and are designed to provide timely detection of water quality incidents in distribution systems. The response components include CM and sampling and analysis, which support timely response actions that minimize the consequences of a contamination incident. In this training module, we'll focus on the CM component. The module covers 4 topics. Topic 1, what is CM? Topic 2, what are the major design elements of CM? Topic 3, what are common design goals and performance objectives for CM? And Topic 4, what are cost-effective approaches for CM? This training module will take approximately 10 minutes to complete. First, let's define CM. CM consists of actions taken to plan for, investigate, respond to, and recover from drinking water contamination incidents. These actions help utilities respond in an effective and timely manner through a planned, coordinated effort. Investigative actions establish the credibility of a possible contamination incident through the review of information from the SRS surveillance components and results from sampling and analysis. Operational responses and notifications help to minimize public health and economic consequences by isolating contaminated portions of a distribution system and instructing customers to not use the water. Remediation and recovery activities are designed to return a utility to normal operations in a systematic and verifiable manner. Now let's discuss the major design elements of CM. CM is composed of 3 design elements: incident response procedures, response partner networks, and communication equipment and methods design element. While CM designs may vary, an effective component requires all 3 design elements. We'll discuss each design element in greater detail in the upcoming screens. The incident response procedures design element has 2 design sub-elements: consequence management plans and risk communication plans. Consequence management plans and risk communication plans describe incident-specific procedures for responding to drinking water contamination incidents and communicating with response partners as well as the public. These response procedures build on a utility's existing resources, such as their emergency response plan. They also clarify roles and responsibilities for utility personnel and response partners. Consequence management plans document roles and responsibilities, notification protocols, and response procedures, and guide a utility through actions that should be taken following detection of a possible water contamination incident. As illustrated in the figure on this screen, CM activities are divided into 3 contamination phases: possible, credible, and confirmed. The possible contamination phase consists of the investigation of a possible contamination incident to determine whether additional information corroborates the information from the validated alert. Information considered during this phase includes the status of other SRS surveillance components and results from site characterizations. If the results from the investigation corroborate the validated alert, contamination is considered credible. During the credible contamination phase, the investigation is continued to determine whether a water contamination incident has actually occurred. Results from laboratory analyses are critical to this phase of the investigation. If public notification has not yet been provided, it is issued at this time. A credible incident is confirmed when there are positive analytical results or a preponderance of evidence demonstrating that the water is contaminated. During the confirmed contamination phase, communication with the public continues, and planning for remediation and recovery begins in earnest. Risk communication plans outline a process for providing target audiences with critical information in a timely, accurate, and effective manner. The purpose of these plans is to guide a utility and their partners in developing appropriate notification materials for target audiences, determining the timing and method of issuing notifications, coordinating with the media, and ensuring a consistent message to the public. The Response Partner Network's design element provides a framework within which utilities and their response partners can effectively and efficiently coordinate their respective efforts during a water contamination incident. The figure on this screen illustrates the various local, state, and federal agencies that may become involved as the investigation of a water contamination incident progresses through the contamination phases. The concentric rings of the figure reflect the manner in which a contamination incident is initially investigated by a utility and local responders before involving state, regional, and federal partners as the incident escalates or when local capabilities are overwhelmed. Responsibilities of utility personnel, as well as local, state, and federal partners, are described in the Roles and Responsibilities section of a Consequence Management Plan. Typical responsibilities of utility partners include: local health departments support the development of public notifications and serve as a contact for state and federal public health agencies. Local fire departments and hazardous materials, or HAZMAT teams, coordinate with local fire units, help protect the public, and assist with distribution of alternate drinking water supplies. And local law enforcement supports investigation activities by controlling access to suspected contamination sites. The Communication Equipment and Methods design element supports information sharing between utility personnel and external response partners. Methods of communication can include landline telephones, cell phones, handheld radios, email, SharePoint sites, social media, autodialer or reverse 911 voice recording systems, and written bulletins. Each of these communication methods has inherent capabilities and limitations, so good communication planning should incorporate a combination of methods so that various parties can exchange information in a timely manner. Now let's discuss common design goals and performance objectives for CM. Design goals are the specific benefits that a utility expects to achieve as a result of CM implementation, such as strengthening a utility's incident command structure by making it compatible with the structures of response partner agencies, improving information sharing and communication by establishing procedures and protocols and risk communication plans that allow for effective communication not only within a utility, but also with external stakeholders, such as customers and the media, and strengthening interagency relationships by working collaboratively with public health and emergency response partners to develop response procedures. This process allows a utility to establish relationships with local, state, and federal partners to provide support during any type of emergency. Performance objectives are measurable indicators of how well CM supports an SRS to meet design goals established by a utility. Throughout design, implementation, and operation of an SRS, utilities can use performance objectives to evaluate the added value of each capability, procedure, or partnership. Specific performance objectives should be developed by utilities in the context of their unique design goals. Examples of performance objectives include timeliness of response and sustainability. CM supports these objectives in a number of ways. For timeliness of response, CM relies on planning to reduce the time required to notify response partners, deploy field personnel and equipment, collect and screen drinking water samples, identify and implement operational responses, issue public notification, and restore the system to normal operations. For sustainability, utilities should design CM to realize benefits that justify the costs and level of effort required to implement and operate the component. Benefits include the ability to effectively respond to all hazards and improved coordination with other agencies during a range of situations. Costs include the labor hours required for utility personnel and response partners to develop response procedures and conduct exercises. The last topic we'll cover is cost-effective approaches for CM. Utilities can take a number of simple, relatively inexpensive steps to develop the foundation for CM, such as develop an initial consequence management plan to guide basic actions, such as forming a utility incident command structure and implementing operational responses. Establish a response partner network that includes potential stakeholders and their resources. Outline emergency communication and notification procedures, such as primary and alternate communication methods to reach both internal and external partners. And develop drinking water advisory and public notification templates. You might discover that your utility already has some of these suggested capabilities in place. If this is the case, implementing CM will be much easier. Thank you for completing EPA's training module for water quality surveillance and response systems. If you would like to learn more about the design and implementation of an SRS and its components, Additional training modules for each of the 6 SRS components are available on EPA's Water Quality Surveillance and Response website. If you have specific questions, please feel free to contact EPA